Right, it's working. Good afternoon. Is serverless locking us in? That's what many developers and thought leaders believe. But what if the real problem is not serverless itself, but it's about how we architect our code? So let's have a look at some building blocks that can help us keep our business logic cloud agnostic. Spring Cloud Function, together with clean architecture and Gradle modules. The key takeaway is a framework to keep your business logic cloud agnostic. I'm Elena van Engelen. I'm a senior software engineer specializing in Kotlin and cloud native solutions. I currently work as a lead engineer at Azure. It's a part of life and pensions of the NN Group. I'm also an author of Kotlin Crash Course book and a blogger on Kotlin and cloud topics. And what I can say is, if somebody asks you to write a book, don't do it. Really, it's like giving birth to another child. I already have two, right, real ones. But this one takes a lot longer than 9 months. So my advice, don't do it. Anyway, what is serverless and function as a service? It's not like you don't have any servers. You do have servers. You just don't have to manage the infrastructure. You don't have to scan your container vulnerabilities. You don't have to patch your operating system. You don't have to worry about the hardware. It's resources on as-used basis. It scales automatically and is triggered by events. So even though containers also can scale automatically, typically in a container you have a microservice or you might have monolith, and if it scales the whole thing. As we are Kotlin developers, we know that functions are very simple. They have one purpose, input and output. So the microservice or your product will actually be built with multiple functions. So only those functions that require scaling and that actually get the requests will be scaled. So we're very resource efficient. So you have HTTP requests maybe in your service, and you have some asynchronous message processing. You might have some jobs running in the background, and only those parts that require scaling will scale. So what are the common function as a service use cases? Let's quickly have a look. The REST APIs, you might think, what about cold start? But the recent developments in major cloud providers actually really mitigate that. So for example, AWS snap start with priming. If you use it correctly, it will really diminish your cold start. You won't even see it in P99. And for example, in Azure Elastic Premium. So you can use it for IoT. This is really a good use case. I actually used it in a company called PostNL. It's the biggest parcel delivery company in the Netherlands, handling like 800 million events per day. So really good. Data transformation, click streams, things like that, scheduled tasks. You don't want to be having a container waiting to run a couple of times a day. So, okay, functional as a service makes our life easier. So what about portability? We already asked that question. So let's look at the Spring Cloud Function, clean architecture, and Gradle modules to see how that can help us. Spring Cloud Function in a nutshell. So basically the bottom line, it allows us to run a Spring app on a function as a service. That's the bottom line. Therefore, we can use our favorite Spring Boot features such as auto configuration, dependency injection. The Spring has got really big ecosystem that you might want to use. And it does it using Spring Cloud adapters. So Spring Cloud adapters, you have an adapter for AWS, you have an adapter for Azure and multiple other clouds. You might actually create your own one if your cloud is not being supported. So it's quite a simple concept. So how does it actually work? Let's just look at the code immediately, so we can visualize how it works. So look at Azure function. First, we need to import the cloud adapter, which is specific to Azure. And then we need to define the function entry point and trigger. In Azure, you need to actually combine those. So you give the function name upload document, for example. This is a hello world example of an HTTP trigger. So we define it as an HTTP trigger, so it's going to be handling post requests on an endpoint called docsflow, and it has some basic authentication API key. So because it's a demo, we're not going to worry about too much security here. So this is a hello world in Azure. So what does it look like in AWS? So on, first we need to deploy it, obviously, because you can't just deploy your code without defining your infrastructure. So we use infrastructure as code, and in this case, to do it in Kotlin, I'm using Terraform CDK, and I'm using Kotlin to define my infrastructure. So in order for my Azure function to run, I actually need a function app in Azure. So I'm defining that, and because I'm using Spring Cloud function, I can just say that this is my main class of my Spring Boot app, and this will basically work. So if you have Hello World, it will just, you deploy your Terraform, and it will just run if you do a post request to that endpoint. So AWS Lambda, again, you need to import your specific Spring Cloud adapter for AWS, and then you need to define your entry point. But where's the trigger? So you can see here, so we have the upload document. It's a bean, which basically standard Spring Bean, right? So it's got a name, upload document, and it's got cloud-specific parameters. But it's also a hello world, but it doesn't have a trigger. That's because in AWS, the trigger for HTTP will be in the API gateway, and that will be defined in your infrastructure as code. So first, let's have a look at AWS Lambda. So we need to define that in our CDK. So there we have to actually say that the AWS Cloud Adapter is our handler. So this is actually a class within the Cloud Adapter. And then we also need to say that this is our, the function that we want to call is upload document. And again, we need to say define the actual main class that we're doing. We are the main class of our Spring app. So this is also going to work. It's just hello world. And let's have a look at the trigger, just a simple example. So the trigger in AWS is going to be defined as an API gateway. So here I've got a docsflow as path. I'm accepting post requests and also have a simple API key as authentication. But we're not going to build Hello World because anyone can deploy Hello World on multiple cloud providers. We're going to build a real application. So let's have a look what we're going to build. I'm going to go back to my experience in writing a book. Every time I was writing a chapter, it had to be reviewed, and I had to do it all via email. So I would send an email to the publisher, and they will do the editorial review, give me comments, I have to fix that, then it will go to the technical review. I'll get some comments, fix again, and then it will go to the final editorial review. So quite a manual process via email. So let's automate it, make it a little bit more modern, and add some business logic to automatically review something before the actual reviewer will take the document. So this is a solution design for both clouds. So you can see that we're actually using the actual cloud components to do this. So in Azure, we're going to upload the document via HTTP endpoint. It could have had a front end, but I'm just using Postman. So upload a document. It will use some publish-specific validation before it uploads it to a storage. And once it uploads it to a storage, that will trigger another function to actually do a review of the document. And once the review, automatic review is done, that review will be included in an email to the reviewer with a secure link to the document. And that's the same with AWS. So I'm going with HTTP request via API gateway to Lambda. This will validate with the same business logic, put it in a S3 bucket that will send an event to AWS Lambda, which will again execute the same business logic to actually do a review, and will send an email via SES, simple email service to the reviewer. So that's basically our example to show how we can separate our business logic. So what we're going to do, we're going to separate our business logic from the cloud-specific code using clean architecture. This is a specific variant of clean architecture for serverless. It's very simple, and that's because we're using a function. So a function has a lot less responsibilities than your typical microservice in a container. So you don't need that many layers. So we have a domain layer, and this domain layer will have some domain model and objects and some basic domain logic. And then application layer will have some use cases and business logic for that. And infrastructure layer will have your specific persistent and cloud-specific code. And also your Spring Cloud function entry point, which you saw completely different from each other. And the cloud dependencies. So any cloud SDKs and any specific Spring Cloud adapters will go there. So actually your application doesn't have those dependencies at all. And you have the inward dependencies, so that means the domain cannot access any classes from the application, and your application cannot access infrastructure because Gradle modules will prevent that. You will not compile. So really quick example, what would go in there? So let's look at the pension sector. It's not boring. It sounds boring, pension, but it's actually not. So a pension has a participant in a pension fund. So you have a pension fund and a participant, and you have life events. Why do you need life events? Because in a lot of countries, life events actually have impact on your pension. So let's have like some examples from the Netherlands, for example. So every country's got their own business rules for pensions. But so basically, if you get married, and that event is important because we register that. So if you ever get divorced, your partner will walk away with some of your pension. So they will become a participant, and we have to process that automatically. We don't want to do anything manually. So this is business rules. Another very complex business rule and very funny one. So, well, not funny actually, it's very sad. So if you die, right, so there are some beneficiaries of your pension, and those beneficiaries also include your ex from 20 years ago. So your kids, your partner will have a claim on your pension, but also your ex from 20 years ago can claim the pension for the time that they were together with you. If I knew that, I would probably be thinking twice about getting married in the Netherlands, but okay, never mind. So for our use case with Docsflow, obviously that's a lot simpler. So in a domain, you might have some document metadata. In application, we have two services or two business logics. So validate your document and review the document. Infrastructure will connect us to our blob store, S3, and email service, whatever, and our triggers. So this is how the Gradle modules look. So we see that we have domain and application modules, and they contain our business logic. And then we see that we have two infrastructure modules, AWS and Azure, and those actually have the SDK and connecting logic to the cloud. We also have a CDK, AWS and Azure, but those are not part of the package that we deploy. This is basically for infrastructure as code. But what we do is we package your business logic together with the AWS or together with Azure, and we only deploy that. So AWS package will have nothing with Azure or any dependencies, and the other way around. So this is how we separate it, so we can deploy the same business logic to both cloud providers. So this is how Gradle looks. I don't think I have to explain it here because everybody here is from Kotlin. So yeah, so you define your Gradle modules, and for each module, you say what the dependencies are in the inward dependency, basically. So this is what we're going to build now. We're going to put the same business logic on AWS Lambda and Azure Functions, and then we're going to seamlessly connect that business logic to specific cloud services. So let me just move to my IDE. So I wasn't able to make this bigger for some reason. Never mind. Right, so here I have the, if you can see, application module, domain module, and I have the infrastructure. And the infrastructure, I have two modules, AWS and Azure. So what we're going to do now, we're going to inject the business logic into the hello world examples. We looked at them in the slides. So quickly looking at the business logic, so you have a little bit of idea. So we have the two interfaces. So one will handle the requests, so it will accept the document, validate it, and the other one will review and send an email. It's actually doing two things, but okay, just for simplicity. Anyway, so this is what we're doing. The implementations are here. We'll look at them later because we want to inject them with cloud-specific, or we want to connect them to the cloud later on because we want to be able to save to the cloud storage. So I'm going to do Azure first. So I'm going to go in and update our entry points. So first we need to inject our services. So we have the, thank you. Yes. It's nice, right? IntelliJ. All right, so let's replace our hello world with the actual handle. Right. So here we're going to accept the document and validate it. That's going to be there, basically. This is implemented in the business logic. And that returns a generic object, which is a response, and then we will convert it to the cloud-specific one to make sure that we can respond correctly with the body and the HTTP code. And this is actually going to process the blob. So this one we didn't look in the slides. We didn't see in the slides. This is in the docs flow blob storage. When we save the document, it will actually trigger this function. Right now, this is hello world. Let's replace that. So what we want to do is review and notify. I'm kind of cheating here with two things in one function. Right. So we've done that for Azure. Nice. So Azure now is connected to our business logic. Let's do this for AWS. So again, we need to inject our things. You actually could inject it here, but yeah. You can actually inject it in actual beans in AWS. So let's do handle. Oh, it's predicting everything. Look at that. It knows me. Right, so let's put this. So we want to replace the hello world again with the handle. So this is going to handle our. Oh, it didn't predict my thing here. Okay. Okay, so this is going to handle the document that we are uploading, and then it will convert the response here to the cloud-specific response. Okay, so now we want to process the document. When the document arrives in the S3 bucket, this is the function that's going to be triggered. So we want to replace the hello world with our business logic. Okay, let's see if the IntelliJ knows what I want. Right, so yeah, so we're going to review the document and notify. So this is done. So what we want to do now is we want to inject our business logic with connections to the cloud without it even knowing which cloud it's talking to. So basically in our application module, we define some interfaces. So this is an interface to send an email. Yeah, just send an email with a review. And this is an interface to save the document and generate secure access URI, two separate functions. I called it an interface. That's not a good idea normally, but just so that it's clear, it's an interface when we inject it, so we can see it's not cloud specific. So these interfaces are actually implemented. So basically, if you go and look inside the implementations, you can see there are two implementations, the S3 and the blob store, and they basically implement the cloud-specific things that will make this work. And that's actually inside the infrastructure. So let's update our business logic. Let's go to the docs flow first. This is our docs flow with some very, very complex validation, which just returns true. So this is some complex validation from the publisher. And we wanted to execute it on the document. And then if it's OK, if the validation is OK, we want to actually save that document. So instead of hello world here, we're going to actually do, let's just inject first, actually. So yeah. So it knows I don't want to use interface in the name. See that? All right, so object storage. We want to use that to save the document. So we save that. So once we validate it, we can just save that. So that's it. And now we want to actually update our document review business logic. So there we actually need two things, because we're actually doing two things. We are going to review the document and also send an email. So we have two services here. All right, object storage and notification service. So let me just get rid of that. So, so now here we want to generate a secure link. So the secure link will live 24 hours or something like that. It's like secure enough for that kind of work. So we want to generate URI. So this is the secure URI. This is the one that we will include in the email. Then we have some very complex business logic to review the document. Actually, I'm just generating some random string. I didn't plug in AI here or anything. Everybody's talking about AI. Let's just, do some mock stuff. So this is like business logic that the publisher could be executing. So let's send an email. So we're going to use the notification. And send the email. So now we've plugged everything in. Let's just make sure that nothing, because I'm going to deploy this to both clouds at the same time now. So what could possibly go wrong? Let's just build it first, just to make sure we haven't made any errors. Okay, so what we're going to do now is right. So if I go back to my browser, I should now see two workflows going for the two things. You can see here AWS and Azure have started to deploy. So it's going to build the package and deploy. Let's just quickly look at what we're doing. While it's building, we can just have a look. So basically, we had the three layers, the application, domain, and infrastructure. And then we also had CDK. So CDK had the two modules, AWS and Azure, and that's where I had my Terraform CDK to define the infrastructure. It's a lot more code than I showed in the slides. So at the end, I will show you where the examples are if you want to actually look at the full code. And GitHub, I've got GitHub Actions to deploy. So I've got in the feature, I will deploy AWS and Azure. So this is how it's going to be deployed. Let's have a look at one example. It's going to be a little bit fast, sorry, because it's quite a lot of code. I'm not going to go in too much into it. But basically, we build a package, we upload it to storage, the actual package that we're going to deploy. And then we just run Terraform init, plan, and apply. So that will just put our function into the cloud. OK, so let's go back to here. And then we're going to go into the slides so I can talk a little bit more about Terraform. So Terraform has multi-language, the Terraform CDK has multi-language support. Terraform CDK basically just generates Terraform files. And multi-language support means you have Java and therefore, obviously, Kotlin. It has Java it doesn't have actually Kotlin specific one, but we can just use the Java one. C#, Python, TypeScript, Multi-cloud compatibility, we can deploy to multiple clouds, so it helps, of course. You can obviously use specific CDKs for the cloud, but it does help to just speak the same language, even though you have to have a special dialect for each cloud. Reusability, we can reuse Terraform modules written in other languages, or Terraform directly. Predictable changes, we can see the difference. So if I change my infrastructure as code, I can see what's going to be changing in the cloud. So what's before and after image. So how do we do that? So Terraform CDK has commands like cdk-tf get, which will get your dependencies, and synth will generate the Terraform files. This is very slow. So I only use it because then I can write everything in Kotlin. But this is basically, I wouldn't do this in the pipeline because otherwise your pipeline will be slow. So only when you change your infrastructure, generate your Terraform files. And then you just deploy your Terraform files. And this is just a standard deploy for Terraform. So let's have a look at the demo. So hopefully by now our build deployment has finished. AWS is faster than Azure, I knew that. So let's already look at that. So we're going to look at our AWS. So this is AWS, hello world. Let's upload chapter 13. I'm very lucky. It's talking about serverless, but with HTTP4K, so it's probably going to get a bad review now from Spring Cloud Function. Right, so we're uploading that, and if you look here, you can see I'm pointing at AWS. So we uploaded it. You can see that there's a location at S3. I actually forgot to show you that S3 was empty before we did that. Never mind, I'll show the Azure one in a minute. Right, so let me just go to the browser again. So, yeah, so basically now in the S3, where's my S3? There's my S3, so it's empty. I just didn't show you that. So if I refresh, there it is. So now I should have my email. So I should have an email with secure link. So let's go to my mail. Just don't ignore my other email, please. Right. So this is secure link, very long. That's because it has a token and everything. And basically, it's not happy with my chapter, of course, because it's using HTTP4K and not Spring Cloud Function in there. So I'm going to click on there to download this because I'm a reviewer and I want to review the chapter. There it is. Just double click, so this is chapter 13, I can review it. Okay, so by now Azure should have finished because this was a very long talk, so let's have a look. We're going to go to our, yes, Azure is finished. Hello, hallelujah. Okay, so let's go and do the same with Azure. So what I'm going to do, I'm not going to forget to show that Azure is empty, so we've got this storage, have refresh, it's empty, docs flow storage, blob container, it's empty, so we're now going to use the Postman. I'm not very good at front end, otherwise I would have done something there. So Postman, going to the Azure, and we are going to upload chapter 8, just for a difference. This is about functional programming, and we're going to send that. So let's hope this works. All right, so this is actually pointing at Azure Function. You can see it's saved it to blob storage. So I can just go back to my browser and refresh. Yeah, there it is. So we've done exactly the same thing, deployed the same business logic, and it's doing what we want. So if I go to my mail, again, I should have a mail from Azure as well. And this got a link as well. And it's also not completely happy with the chapter. So let's just download the chapter. And we should see a chapter 8 coming up. There it is. Okay, so we deployed the same business logic, although I didn't actually implement much in there because obviously you have to use your imagination there, what kind of business logic you can put in there. So let's just go back to the browser. Yeah, let's go. Right, so yeah, so the key takeaways are the recipe for cloud-agnostic serverless for function as a service is make sure you keep your business logic separate from the cloud provider code. You don't have to avoid cloud features, really you don't. You can go completely wild in your CDK and in your infrastructure. Basically, cloud providers, they copy each other. It's like AWS looking at Azure, oh, I like that. And then Azure is like, oh, yeah. And then all they do is just give it another name, another packaging. They put it somewhere else, package it here. So all you need to do is just create code that's boilerplate to describe the things you want. So basically, you need to design your system from your use cases and not from what cloud provides. And then it will be fine. So you just, yeah, basically, I think now with AI, you probably can generate most of that as well. So Spring Cloud Function, it allows us to actually inject, so it's because we're using inversion of control and dependency injection, it allows us to inject our business logic with cloud-specific functionality without the business logic knowing about it. So you don't actually have to use Spring. It just, you can actually use another framework to do that. Gradle modules, you can also use Maven, but so Gradle modules, they allow us to enforce this separation. And in my experience, we first started with packages, and I saw that, with pressure of time, people just still do, it will still, come into the wrong place. So if you use Gradle modules, it's a clean separation. You make sure there's no SDK in the business logic, and this way we could actually go from container to function and from function to different cloud providers. There are some banks even that want to run multiple cloud providers at the same time. And Kotlin, of course, everywhere. It's perfect. And actually, it contributes to portability because it can target lower versions of JVM. If you look at when AWS went to Java 21, it was a lot earlier than Azure did. So actually, because you're not worried about the version of JVM, you can use the latest version of Kotlin. Kotlin is actually really contributing to our portability. And Terraform CDK, some people love it, some people hate Terraform, but yeah, it does help us speak the same language when we deploy to multiple cloud providers. So I'm actually very early. That's nice. I hope that wasn't too fast. I actually say try it at home. So if you have some questions, you can connect with me. It's my website, and there's some links to my social media. I also have a blog on AnandTech, and there's 2 different examples you can try out. So this example that I showed is also there. I actually have some AWS vouchers. It's AWS credit vouchers for $20, and I have 15 of these. If somebody wants to try this at home on AWS, I don't have Azure vouchers, you can come up to me and yeah, first come, first served. I've printed it all out in the hotel. So, yeah.